What's going on? This is Graveroth. I noticed that practically every beginner has trouble creating spirals and helices in Houdini simply because there's really no spiral tool or spiral node in Houdini. And it really is rather simple to do. It just takes a little bit of that high school trigonometry you were convinced you'd never use. So here in Houdini, I'll just go ahead and create a three-way split to my viewport just so you can see what's happening as it happens. The whole idea is to use a little bit of math to warp a line into a sine graph in one view, in one plane, and into a cosine graph in the third dimension. So a combination of these two deformations would ultimately form a helix or a spiral. All right, so I'm just going to pick up the curve tool and create a simple line in the front view. Make sure grid snapping is on, and I'm just going to click, and there's a 2-point line. Obviously, it's going to need much more than 2 points if I'm going to warp this line into a sine graph. To add a little bit more detail, I'm just going to add a resample SOP, a resample surface operator. So in the resample SOP, I'm going to uncheck maximum segment length, and I'm going to turn the number of segments up to 100, and I'm going to set the display flag to the resample SOP and turn on point numbers in the viewport. Now I have points numbered from 0 to 100. And like I said, I'm going to create a sine curve out of this, and the way to do that is to use a point surface operator. And I don't want to use the new points SOP, I want to use the old point SOP, and I'll tell you why it works better. The old point SOP lets you compartmentalize each unit of the vector, each component of the vector, the XYZ vectors. The new point SOP requires you to type in a single vex expression, and I found out that using 3 different H script expressions works better. It's more convenient, and there's less to type. And for the Y component, which is just straight up and down, I'm going to type in the expression $PT. The dollar sign says it's a variable, so $PT divided by $NPT. And this simply tells Houdini to recognize each point as a fraction of the total number of points. So point number 0 would compute to 0, point number 50 would compute to 0.5, point number 75 would compute to 0.75, and point number 100, the one at the very top, would compute to 1 whole. So in order to create the sine curve I'm talking about, I'm going to make sure the X transformation is driven with a simple expression, sine $PT over $NPT times 360. And now you have one complete revolution distributed in a sine graph. One complete revolution being 0 to 360. As you can see, the line is still straight up and down in the right viewport, so we're going to transform it into a cosine graph by driving the z component of every point with a cosine formula. Cosine $PT divided by $MPT. Once again, this just takes the points by number and makes them a fraction of the total number of points, just so you can multiply them by 360 and get the cosine of that value. And as you can see in the perspective viewport, the synergistic combination of both deformations, the sine and the cosine, gives you a spiral. And this spiral is one revolution because we're talking 360. If you wanted 2 revolutions, you'd need to multiply that by 2 in both the sine and the cosine formulas. So you multiply by 2 and get the sine and the cosine values of both computations. And this would give you 2 revolutions on your spiral. And it would work just as well if you wanted 5 revolutions. You just multiply 360 by 5 in both the sine and the cosine expressions. Just make sure you have the same number in both formulas as a multiply of 360, which in turn is multiplied by a different fraction for every point, as shown by these 2 variables, $PT and $MPT. And the dollar signs just mean they're variables, which means that there's a different calculation for each point. So this formula handles all 100 calculations for every point. So now we have our 5 revolution spiral. What if you wanted to make the spiral narrower? In that case, you'll need to multiply the whole formula, the whole sine formula, by a fraction and do the same to the cosine formula. As you can see in the left viewport, the spiral is now half the width. And if we just go on and do the same thing for the z component, we'll notice in the right viewport, the spiral is also half the width. And what if you wanted to make your spiral twice as tall? You'll just have to multiply the y component, which is straight up and down, multiply that by 2, and there you see you have a spiral that's twice as tall. If you wanted it half as tall, you'll multiply by a fraction like 0.5. And there you have a spiral that's half as tall as the original. Of course, you can also go ahead and skin this. You could create a circle. And this could serve as a section you would sweep around your spiral to give it some skin. And of course, this circle is much too big, so I'm going to scale it down really, really small. And so I'm going to type in the sweep command, which essentially drops in a sweep node. And since I already have the circle selected, it's going to ask me to select the backbone. The circle always being, the section always being the first selection requested. And I'm going to turn off point numbers so we can see what's going on. So this sweep is not skinned in the way you expect. I could just go ahead to the output and turn on skin with auto closure. And of course, I could still make this circle smaller if I wanted. Alternatively, I could go into the point stop and increase the height of the whole spiral. it didn't auto close, so you could just drop in a polycap. And what that does is it adds a polyfill node, which looks for holes to cap. Alright, so that's it for today. Check me out on my Patreon if you need more detailed tutorials. That would be patreon.com/Grapheroth. Alright, take care. Have a good one. Grapheroth out.